Welcome back to Designing Compute Solutions. In this section, we're going to be talking about containers. Now, we mentioned containers before as being an option for supporting microservices, and of course being a primary option for compute services in general. And as we talked about before, when you're looking at using containers, you'll want to consider whether or not you're doing a lift and shift of resources or applications, or greenfield, new deployments. One of the things that Kubernetes can provide is identity and security management. So you can configure an AKS cluster to integrate with Active Directory, and you can use existing IADs and security groups in your Active Directory environment to provide permissions for the cluster. You have built-in logging and monitoring. It's included in the Azure Monitor for containers. Custom Kubernetes installations normally require a monitoring solution, and they need install and config. You can manage Kubernetes software upgrades with cluster nodes. You cordons off nodes one by one and will drain each node before it actually accomplishes the upgrade. So you have kind of a nice rolling upgrade environment, and you never really have to drop service completely in order to handle upgrades in a cluster. Containers supports GPU-enabled node pools. So if you have any heavy compute or graphic-intensive workloads, you can rely on Kubernetes to run that for you. And you can do auto cluster node and pod scaling. Now, Kubernetes supports two scaling options. That's horizontal pod autoscaler and the cluster autoscaler. Now, when you're deciding whether or not to scale up or down in a large containerized environment, it can be a little bit tricky. So you can use the horizontal pod autoscaler or cluster autoscaler. Horizontal pod will watch the resource demand of the pods and will increase them to match that demand. Cluster autoscaler watches for pods that can't be scheduled because of node constraints, and it will automatically scale the cluster nodes to deploy scheduled pods. This can get a little bit tricky. Again, you'll have to keep an eye on your configuration for scaling, making sure that things scale back correctly or that your requirements for scaling up are clearly defined. I've seen some of these environments they blow up pretty quickly and sometimes unnecessarily based on poor configuration. So you really want to keep an eye on that. You've got storage volume support to look at. Kubernetes supports static and dynamic storage volumes. Pods can attach and reattach to the volumes as they're created, or they can reschedule for running on different nodes. So your ingress with HTTP app routing support. Do your apps need to be publicly available? Application routing will allow for easy access to those deployed apps. Kubernetes cluster can be deployed directly into an existing virtual network. So if you've put some time into configuring your virtual network, just as long as you've acquired some space, or rather accounted for some space for a Kubernetes cluster, you can just drop them right in. It's just about as easy as deploying a VM into it, really. And private container registries. If you need them, then Kubernetes will integrate with the Azure Container Registry. And you can also use any other public or private container repos as well. Lastly, Docker image support. Kubernetes will happily support the Docker file image format, so if you're coming from a Docker environment, you won't have to redo all that work you've done. When and why would you want to use the container instances? Well, if you have a task that can operate in an isolated container, simple applications, automated jobs, build jobs, that sort of thing, then a container makes for a nice place to drop them. Containers have very quick startup times compared to a VM, so if you want something to fire up and run pretty quickly, definitely measurably faster than VM startup. Azure containers allow container groups to be exposed to the internet, both via IP addresses and fully qualified domain names. And you can access them in a HTTPS TLS command shell if you want to interact with your application that way. You have full hypervisor level security. Container instances will guarantee your container-held application is as isolated as a VM would be. Mind you, except unlike a VM, it boots quicker and takes less configuration and resources to run. And containers can also direct mount Azure file shares to an instance. Those file shares can be reattached as a container bounces or comes online or offline, scales up, that sort of thing. So you can have a pretty static storage environment that your containers will always access. Now, if you need full container orchestration, any kind of automatic scaling, service discovery in your containers, or if you want to do the, like I mentioned earlier, kind of the rolling application upgrades, then you definitely want to be using Kubernetes. Other benefits, custom sizing. Your container instances can be expanded to meet whatever the needs of an application are, not simply adding more nodes, but just making the container itself beefy enough to run the app out of the gate. Of course, it supports Windows and Linux operating systems. You have co-scheduled groups, and that's basically groups of a lot of containers that will share a single host machine, network, storage, and the general lifecycle. Kind of keeps everything together in one general organized batch. The main container application and supporting role containers can be combined. So this is really a logical conglomeration of the containers. So you have a primary application and then maybe some ancillary functions, and you keep all of those together in one logical group. That's also helpful if you're using containers to support individual departments or development teams. Throw some tagging in there and make sure that they're billed correctly, keeping all of the various moving parts of a given department or application support crew sharing the costs where they need to. And your virtual network deployments. Container instances can drop into an Azure virtual network just like you would a VM, and you get the same benefits for it. And that's more or less the why you would want to use containers. I don't believe this will be on the exam. It certainly wasn't when I took it, but you can actually use containers as an endpoint for application migration when going from on-prem to Azure. So if you have a legacy application running an old .NET web server or something like that, and you don't really want to have to build an entire VM to run the thing when you migrate into the cloud, you can drop those apps right into a container. So that'll do it for the when and why you would want to use Azure container instances. Hopefully you'll join me in the next video where we're going to talk about the old standby, Azure Compute Infrastructure, also known as VMs. See you there.